Hi there. So like what I have promised, let's now have a example regarding how can we find out integrating factor using only or by inspecting our given differential equation. Okay. So do not forget to um, to remember this exact differentials because we will need that. Okay, so this is our given dE, x multiplied by x dy plus y dx plus d of x. And um, as you notice through your through your mind that we have this part here, x dy plus y dx. And something's familiar with this part. We have x dy plus y dx. So we have first times derivative of the second plus the second times derivative of the first, which is this one, this exact differential, right? So let me make, yeah. Okay, as you notice, this part here is exactly this part. Okay, so you need to extend your imagination and you need to think carefully where are some exact differentials here. And as we as an example, we've determined our exact differentials by x dy plus y dx, which is totally the same by writing that we have this one x, and this part here, the exact differential here is also this part because they are equal, right? So we have dxy plus dx is equal to 0. Okay, so from our given differential equation, see this is our equation 1, to this second differential equation. Okay, you can see that we have the derivative of x and y and the derivative of x, right? So we have the derivative of x and y, then we have the derivative of x. And since we've already identified our exact differentials here, we need to it's like adopting the technique in separable equation, wherein we separate the terms of the variables x and y, or z and x, and some other variables, the independent and the dependent variable. Okay, but here in our example we have the derivative of x and y and the derivative of x. And how can we um, make that this part only or must have a function of x and y alone, and this part here must have a function of x alone. Okay, so that on the next step we can integrate these both terms. Okay, so how can we make it that way? Okay, so by inspection, what numbers or variables are we gonna multiply by this part, this whole term, in order for us to have an exact differential equation? Okay, so what integrating factor are we gonna use, or are we gonna multiply to this equation in order for this equation to become exact? Okay, so we need to think of some variable. Okay, so through inspection, what can you see? Alright, so if we're gonna multiply 1 over x in order for us to remove this and making this a variable of x and y alone and making this a variable of x alone. Okay, so if we're gonna multiply this as our integrating factor, then our equation will be looks like this. So we need to multiply this by 1 over x, so we have x over x. Then yeah, so our equation will gonna looks like this. The derivative of xy plus derivative of x over x. Okay, so or we have this part plus the x all over x. Okay, that's 0. Then from equation 3, this is now totally all exact. Okay, so we have terms that we have a purely x alone and term that is a purely x and y alone. Okay, then if we've already been in this part, then we can now integrate both terms. Okay, then how can we integrate this? So let's start in this one. Say the integral of 1 over x dx is just ln of x. Okay, and then our plus c. Let me rewrite our plus c here. How about this guy here? How can we integrate this? So this is simply the integral of the derivative of xy is simply xy. Okay, so do not confused with this form here. Okay, so finally this is gonna be our general solution. Okay, so once again, do not confuse in this term the derivative of xy. The integral of this is just x of y. Okay, it's like having a say we have the integral of dx. What's the integral of dx? We have x. Okay, the integral of dz. What's the integral of dz? We have z. Of course, our plus c. Do not forget. Yeah, right. And another, the integral of the theta. So our theta here is, I mean the integral of this d theta here is just theta, right? Okay, so that's exactly the same by having this x and y here. Okay, so once again, we did the integrating factor found by inspection. So what our integrating factor here? 1 over x. Why? Because we want to make this part here purely x and y alone and this part here purely of x alone. And as or by true inspection, we've noticed that multiplying or dividing both sides by x makes this equation 3 purely exact differentials here. So we have so we can now integrate both terms and then solve for the general solution. Okay, so our technique here is to make our equation and purely exact terms by having or by separating or by multiplying our integrating factor. Okay, so if you are still confused, then let me see you on the next video for another example.